Right, here's another application of area. Given the area of the rectangle is 4xy miles squared, what is the perimeter of the rectangle? Okay, well, that's kind of a crazy question. First of all, let's talk about, they told us the area of the rectangle is 4xy. Okay, well, area of a rectangle is length times width. We know our width is y. Okay, all right. So our length has to be 4x. So that when we multiply, we would get 4xy when we take length times width. So we used the area to figure out what the length of the other side was. Now we're going to find the perimeter. Perimeter of a rectangle, you just add all four sides together, or you can do, since you have two pairs that are the same, you can do 2 times the length plus 2 times the width. Okay, or that would give us 8x plus 2y miles would be the perimeter for that rectangle. Again, you can do it using the formula for perimeter, or you can just add the four sides together. And when you do, you end up with 2 y's and 8 x's, just like we did up above. Alright, here's another application. This one is, again, also looks very complicated, but let's break it down, see what we can do. It says rectangle MNPQ, so this rectangle over here on the left, is similar to RSTU on the right. Given the information marked on the diagram, what's the perimeter of RSTU? Well, what's marked on the diagram? Well, they tell us the perimeter and the area of our smaller rectangle, and they tell us the length of one side of each of them. The only way the perimeter here is going to do us any good, let's see, if this is 3, that means this is 3 if those are rectangles. Okay. The other thing that it tells us is, well, if we have a perimeter of 10, okay, the perimeter is equal to twice the length plus twice the width. We know our perimeter is 10. We know that our length is 3. What would our width have to be on that smaller rectangle? We need the dimensions so that we can transfer over to here and find the perimeter of that larger triangle. Well, that gives us 10 equals 6 plus 2w. So those two sides length 3 take 6 out of our perimeter and leave us with just 4. So you could, without a formula, you could think this through. You could say, well, I have a perimeter of 10. If I take out that side, that leaves me with 7. If I take out that side, that leaves me with 4. I have two sides that are supposed to be the same length, and all I have left is 4 centimeters to cover those. So what would they have to be each? They're both the same size. They would both have to be 2 centimeters. So you can do it with logic, or you can do it by solving an equation. What we want to know is the perimeter of RSTU. We know that we have a side length 5 here, and it's a rectangle, so that means this side is also 5. But we don't know these two sides. We're going to use the fact that the rectangles are similar, because we know that when we have similar figures, their ratios should stay the same. So when I put the corresponding sides 3 and 5 in a ratio together, the corresponding sides on the other should be the same fraction. That's what similar means. They are proportional. So I have 2 and then my x here. 2 was the other side of the smaller triangle. I don't know the other side of the bigger triangle. That's what I'm trying to find out. But I know, again, they should have that same ratio, 3 to 5. We're going to solve for our missing side here. Leave the equal sign in the middle and cross multiply, so we get 2 times 5 on one side and 3x on the other. We get 3x is equal to 10, and I'm going to go ahead and divide both sides by 3. When I do that, I get 3.3, or 3 1/3. I'm just going to write the decimal form of it. Okay, so my missing sides here are length about 3.3. I rounded off. And now I can go ahead and find the perimeter of RSTU. The perimeter, I add all the sides together, so I have two sides that are 3.3 and two sides that are 5. Again, you could do that 2 times the length plus 2 times the width if you prefer. Either way, we get 16.6 as the perimeter of that rectangle. So again, this was kind of a roundabout application to this problem. We used the fact that they were similar to find the missing side, and then added the sides together. Originally on this one I had to find its widths, and what I did was take the perimeter and find out how much was left that wasn't spoken for by the 3 and the 3 to fill in my missing sides. Again, then I set up a proportion. I knew that the ratio for the similar figures was 3 to 5, so that would be 2 to what? And it turned out to be 3.3. I then added all of those sides together on the large rectangle to find its perimeter.